Welcome to your lab on density. Today we're going to determine the density of this potato three ways. The first two ways will require measurements of the mass and the volume, and the third way will require only measurements of its weight in the air and submerged in water. We're going to start with the measurements of the mass of the potato. The mass of the potato is 0.14118 kilograms. Alternatively, you could say 141.18 grams. We'll now determine the circumference of the potato, and then we will assume the potato is a sphere to get an approximate volume. Taking the string that I wrapped around and now lining it up with my ruler, and I see 19.2 centimeters. 19.2. Now, from that circumference, you will be able to calculate a volume, and that's the first part of your lab, using that volume and the mass to calculate density of the potato. We're also going to determine the volume another way, using the displacement method. I'm going to dunk the potato in the water and see how much water is displaced by the potato. First, I'll make a mark at the current water line, dunk the potato, fully submerging it, and make a mark at the new water line. The volume of the potato is equal to the volume of the water that was displaced. I have 200 milliliters of water in my graduated cylinder. I'm going to fill the water in this container up until the water line is equal with the mark that I made for when the potato is submerged. And then I will read the remaining liquid volume. Take a minute to settle down. "75 milliliters. Subtracting that from the 200 that I originally had will give me the difference, which is how much I poured into the second container. 200 milliliters minus 75. The final method that we will use is the hydrostatic weighing method. I'm going to use this force probe to measure the weight of the potato in the air and out. I'd first like to zero the probe with my hook on so that I don't count the weight of my hook. Then hook the potato. And because I'm holding it and wiggling a little bit, I'm going to collect some data, and I'll take an average of that data. And then I'm going to weigh it in the water. This is known as the underwater weight or the apparent weight, because it's going to appear to weigh less. The reason it appears to weigh less is because of the buoyant force pushing up on it. I'll now collect again. and I get an average. Thank you.